start up. But at our school, for the last 2 years with Addressing Common Core, we were very lucky that our school sponsored a committee of 30 teachers over 6, 7, 8 meetings all day, and we put together, and we started addressing 9th and 10th grade speaking and listening standards. And you say, well, why is the science department chair on the Common Core committee? I've always said there's been 3 revolutions I've had in my career. After 6 years teaching regular chemistry, I started teaching AP and realized I wasn't a very good chemistry teacher. And then after 6 years of teaching AP chemistry, I went to Niles West and started teaching there and realized that the professionals I was around, I wasn't a very good AP chemistry teacher. And now I'm in 23 years of teaching, and I think Common Core, differentiated instruction, and my ability, they gave me Chromebooks this year to use in my room with 18 kids as a pilot. I think this is going to be my last revolution of how to teach to a kid, not to a class of kids. I think I'm finally, and so what we started to do was we looked at the Common Core, and we're using the same language across all our disciplines when we teach kids about speaking, listening, reading, and writing. And we had science teachers on this, and so in our lab reports, what we're going to start looking at is the idea of using the phrase claim, reasoned, if I could write, evidence, and then analysis of evidence. So in my first lab, I'm teaching physical science this year. First time in 16 years I taught physical science. And in the first beaker I had sitting there, the copper chloride crystals, the first day of class, I have some kids with needs, special needs, and Sue's been telling me about her kids all these years. And I'm like, Sue, what are you talking about? How do you get... And Tommy's looking at this beaker and he's like, Mr. Hines, I'm like, make some observations, Tommy, what are you doing here? And Tommy's like, Mr. Hines, I got to tell you something about myself. What is it, Tommy? I don't remember things so good. Okay. So I'm like, I'm multiple steps trying to get him to describe, well, our 5 senses, what can we do, sight, and we're not going to touch it, we're not going to taste it, what can you... And finally my co-teacher walks over, she goes, Tommy, tell Mr. Hines what color that stuff is. And in my mind, at that point in time, I'm like, this is how, very logical, sequential, concrete thinkers these kids are. And it really has opened up my mind. And so when we start to do this, we had the kids throw aluminum into copper 2 chloride solution the very first day, and I didn't tell them anything. I didn't tell them any rules. I said, hi, I'm Mr. Hines, put your goggles on, don't taste it, don't touch it, don't throw it at each other, and clean up when you're done. That was my rules for the day. So we threw aluminum into copper 2 chloride. Oops. Aqueous. And they had to make all kinds of observations. Their goal was to tell me whether a chemical reaction took place or not. But first they had to identify what are the components of a chemical reaction. So my physical science kids that have trouble describing what green is went through this and they came up with it got hot, it fizzed, the aluminum's not there anymore, it dissolved. So we used all those rules to describe what is a chemical reaction. Their whole test was, I then took them through iron and sulfur together, heated up. We went through a lab demo and we did a performance assessment of them, going through and using their claim, reason, and evidence. I mixed iron and sulfur in a test tube and heat it. Is that a chemical reaction? How do you know? I mixed salt and water in a beaker. Is that a chemical reaction? How do you know? So you had to give them the positive and the negative. So we're doing this for all of our physical science kids. I'm going to encourage you to really get in and have these kids, instead of giving them the steps of a procedure, give them a chance to design their own procedures. Give them a chance to, like right now we're filtering salt, sand, and iron, and I didn't give them one step in the process. They had to design the whole thing together on a PowerPoint presentation that I sent out. They had to talk about what they know about it, but it's slow. When you're looking at the science and engineering practice from NGSS, you have to take your time and give them the chance to really get in and investigate, tear it apart, and design on their own. I just want to encourage you to do that. I just like this because eventually we'll get to, I don't know what the T and the E is yet, but it looks like create to me, and that's what I want to get to eventually. I don't know what to put down here. That's what's coming.
So Mike, just real fast on that.
Yeah?
Carl and I went to a workshop with a guy from Oklahoma, somewhere in Oklahoma, and he does that same thing, but he rearranges it so he does claim, evidence, reasoning, and he tells his kids to be clever.
Oh, I like that. And we got into the fact that in science, in English classes, I think they do this a little bit differently than we do. It used to be something called Melcon, right? I don't know if you've heard that, right? The whole, so we're changing over to this, and I can show you our argument diagram here in a second. But in science, these really are kind of one and the same, right? Like, how do you separate those in a lab? Like, if it fizzes and bubbles, that's my reasons that I'm making this claim and my evidence. Haven't gotten to this point yet. Like, what is the analysis? Is this really like, it fizzed, but I don't know if it's a lab. It changed color, right? So I have to analyze that. Did it change color because something else happened or because I put food coloring in it? So we'll get to that point eventually. Just not quite yet. With Jill's element, compound, and mixtures that she has over here for her AP kids, that looks like this. We all start out there with elements, compounds, and mixture. I have to share what my cooperating teacher did. She would just do, we did this, like we did 2 colors, right? And I would do this on a large scale. Here, just quickly get a pen. I know you're not, right? So we did this in the first day class. Write either an element, a compound, or a mixture on there, right? Write an element, compound, or a mixture on there. Real quick, go fast. Element, compound, mixture. Hurry. No, not the word element. Write an element and kind of something. Give an example of an element, compound. Not yet, keep it at your desk. No, you copied hers. It doesn't matter. Some element, compound, or mixture. Anything. Oh, yeah. All right. Element, compound, or mixture on each one. Go. Give me a mixture. Give me an element, compound, or mixture. Give me an element, compound, or mixture. Awesome. Now crinkle it up in a ball. We really did this when we did it on large sheets of paper. It was so much fun. Okay? Crinkle it on, right? Crinkle the ball. And then we had a snowball fight in the classroom. Right? And so what you did, no, singly, right? So you throw yours at them, and they throw theirs at yours. And whoever got them picked up off the floor and sorted an element, compound, and mixture the right way first won the game. You know what I mean? And it was just, they could either put symbols down there or, you know, and they had a hard time at first, but it's just kind of a fun way to get kids up and interacting in the classroom. All right, Jill is giving you the hook off stage.
Sorry.
Bye.
We're going to do one last